Hi everyone, hope you're doing amazing. I'm Sayantika and I'm very excited to be here today presenting at the DataCon LA conference. Today's topic that we would be touching upon is life factor and its impact on visualization. In our world, today we are totally bombarded with a lot of visualizations around us, which are fairly getting complicated, as in the data is getting complicated, the visualization is getting complicated, and so the cognitive load is also increasing. So once we see a visualization, we there are so many factors playing, we might not even able to gather the right insights, right statistical insights that the visualization might be presenting. So this session is all about having the understanding how exactly we can figure it out, how a visualization is communicating the statistical meaning, or is it communicating a different meaning from what it is expected to do, blindly not following the parameters which are giving us the insights, but rather having a more of a adding a layer to it, so that now we know the filter layer, and that's when we would be able to get the exact insights what it's going to be presenting. Today's agenda, we would be starting with a little overview. We'll be talking about history of how the visualization came into picture. This is very interesting to see that visualizations are being utilized from maybe thousands of years, and only today we are seeing it in more often ways. So we will just touching a little bit how the history has presumed visualization, then life factor and why should we worry about it. It's just how the title communicated it, life factor and visualization. So we will deep diving it and understanding what exactly this term means and how we can incorporate in our day-to-day visualizations and insight that we build. Then we'll be talking about the primal instincts of a human being. Right from our childhood, we have been looking into different aspects of a surrounding, as up is higher and down is lower. A very big bowl is something having a large volume, whether something small is having a smaller volume. So these are some primal instincts that we are having embedded in our minds. So we'll be also a little bit deep diving how they are violated time to time in certain visualizations that we might be seeing. An interesting case study that we will be looking into, and few takeaways. That's me. Uh, in short, I'm all about code and community. I am a fond community member in different community like Python Software Foundation, PyLadies, Django Software Foundation, Women in Analytics. I play various different roles as a mentor, as an organizer, as a speaker, kind of wearing a lot of hats. But would love to interact with all of you. Feel free to reach out to me. I love talking about data, community, code, and D&I initiatives that we are currently focusing in our Python software work group. As a profession, I am a data engineer at Quansight, and I'm also a student as of business analytics at ISB, Indian School of Business. This is a little bit about me. The fun part. Now we would be deep diving into the historical aspects of visualization. This really gets me excited because we do see a lot of talk about data science, analytics, engineering today in 21st century, but going back when there was no such concepts, there were cartographers who were drawing amazing graphical representations and also representation of maps that we call at that time. So this is one example which I came across and was one of the very first, or one of the prominent that got famous, that took into account the concept of scale. So this was one of the first graphical representation of by John of the Britannica Road Atlas, where there were multiple plates and each plate represented a section of the atlas. Here it is represented as 1 inch equal to 1 mile. And the takeaway from here on was scale is very important. In any visualization, at any point of time, what the information has been communicated, scale is absolutely important. There's another very interesting plot by William Playfair, where he represents the prices of wheat, the weekly wages, and ringing more over the 250-year span from 1565 to 1820. So this graph has been divided into multiple vertical section and two horizontal sections. It is hand drawn. There were no technologies that were able to do such graphs that we see today, such complicated graphs that we see today, but rather it was hand drawn. And we see an interesting overview how over the centuries, the prices of different commodities have been increasing, and how the monarch is functioning over these years. And the visual aspect that it presents is appealing. It's just like a city I'm seeing, and it's how the city is growing from one century to another. There is a fall, there's a dip in 17th century, and there is again in 19th century, we can see an increase. This is one of the interesting and one of the complicated formats of how things were starting to be represented in early 1821. And from there on, there were multiple different scales that was introduced. There were different graphical interpretations that were introduced, and we will see a lot more in today's presentation. Now, from here, we will be talking about a lot of modern visualization that we come across. How do we exactly see a standard plot? Like, how many dimensions can we introduce in a plot? Suppose I have a data set where I want to express a lot of action items in one visualization. So how exactly, and what is the theoretical limit that we want to present? So there are at most 6 dimensions that we could present. So practically it's 5. There's X axis placement, there's Y, through size, color, animation, shape. Color and shape are interchangeably used, and it's advisable that we don't have both of them together. These are mostly used to represent some categorical entities, where one category would represent by certain, say, red color, other category could be represented by a blue color or a different shape. Texture is something which we can see in red. In few graphical representations I have been coming across with the texture format, it is very specific to the domain that we might be working into. But in today's modern visualization, texture is not often incorporated, and it is not considered as a standard practice to have the element added to your visualization. But again, there are many visualizations out there that it's incorporating the concept of texture. So it would depend on basically the domain which we might be working in and how exactly it adds value. It's all about adding a value and reducing the cognitive load on the user. This is one of my favorites. So this is done in Tableau, this entire representation. This is a replica of a Hans Rosling Gapminder, which he presented in his talk. And this has been exactly replicated using a data set in Tableau. The x-axis represents the fertility rate, the y represent the life expectancy, the color are the continents, the size is the population, And animation is, as you can see, it's going on and on. And post that, I have also introduced that you can also see the trail. So if you click on a particular bubble here, so you can also find the trailing. So how exactly the fertility rate over the years is changing with the life expectancy for different continents over here. The overall colors are representing the different continents, but each small bubble inside represent the country that has been belonged. And there is also an annotation on top of it, which talks about certain information, their GDP, their population, etc. The size of each bubble represents the population of that country. So there's one of the interesting way where 5 dimension comes together in one plot. So it's communicating a lot of information. We can also plot it in different sheets or different plots and combined in a dashboard. But when we look at in this way, we can have a lot of, even our minds are more intrigued by seeing those, and we are able to make a lot of sense and get a lot of information by just one graphical interpretation. Now, the very interesting and obviously the crux that we are all talking about is the life factor. Life factor, why should exactly be worried about it? So as I was mentioning right in the sessions starting, with the increasing complexity of the graphs. I was there before a few weeks back, I was looking at complex way that the pandemic has been changing the economic sector, the hospitality sector, the tourism. There was one graphical interpretation of just seems like a virus, and inside the nucleus, there's something, a different representation, each were cross-sectioned into different countries, and it was a very colorful. I was blown away. It was artistic, but unfortunately, I couldn't take any statistical meaning with me and understand that properly at my first glimpse. So life factor is one such rule. What we see and how these scales are getting manipulated. This is one very important aspect why we should not vary or manipulate the scales, and we should not violate the primal instinct. So it's a combination of these two factors: scale, the primal instincts, and how they come together. So I'm just going to read these 4 lines on the screen, which are there. This is a little text heavy slide, but from here on, no text for sure. So Tufte introduced the life factor concept. It is said that it's a ratio between the effect in the visualization divided by the effect represented by the data itself. What it exactly means, we will looking into our future slide. A nice formula in red, just one simple calculations that we might want to see here. So what it states is that here it is a graphical representation of fuel economy standards for auto. So late in 1985 and in 1987, how exactly the fuel economy standards are been evolving. So at the very fag end, we can see that a line is representing 0.6 inch long. Line is representing 18 miles per gallon, while at the very front, it is representing 27.5 miles per gallon with a 5.3 inch long. A scale should always be evolving linearly. So if 20 is represented by 2 centimeters, 30 should be represented by 3 centimeters, and so forth. It should be a linear scale. So here we are just taking a difference, like second value minus the first value. These are absolute values. So here you can see the mods on both the sides. we take the percentage of it. Overall, it's like 783% divided by 53%, and we get a value of 14.8. 14.8, which states that the information which has been communicated from the graph and the actual information from the data varies by a 14.8 factor. It's a factor, it's a multiplied factor, and it's huge. So life factor technically should be between 0.95 to 1.05. So one being the ideal, it's one, it's good, amazing. But there is a certain plus and minus of 0.05 that has been incorporated on both the ends. So here you can see how exactly, though we can see the lines getting increasing and there's a road, the perspective of the artist is being shown, but is the information being communicated right? I would always presume that over the years, 1985 was the best, and maybe the end, what we see is it's not that great. So this is one way how exactly we can interpret the life factor mathematically, adding some mathematics to it and getting to a conclusion. Life factor continued. So now we saw in one dimension. So how exactly life factor could be in two dimensions? Two dimensions, when we talk about it, it's area. Three dimension is volume. So right now we are talking about the area aspect. So use of incremental scale, height plus area introduced in the same graphical representation is called squaring effect. From this interpretation, you can see that this is x. If this length is x and this length is 2x, while when I see in these two representations, they are increasing in both x axis and y axis. So basically the area that has been representing is maybe 4x from what has been represented by the little one in here. So this is one example how squaring effect would give you an impression that, first of all, when I see into certain aspects, I always tend to look at the volume game. I am not very keen on reading the text that is behind the volume that has been represented. Same here, that we can see 10 is represented by a small bubble, while 30 has been represented by a big bubble. These can be seen in a lot of maybe marketing decks, which we might be coming across. I have come across a few where certain numbers, though the annotations are rightly represented, but the amount, the volume, or the area, or the one-dimensional scale that is being represented is way beyond proportion that it should be. And it should not be. Obviously, that is introducing bias in how we are presuming things from our eyes. I would be always interested to see a very big bubble is amazing, while a small bubble might be just a very little revenue or a sales value. Going forward, this is again squaring effect in action. We see a number of bias about Windows is almost, it's shown as negligible, while Macintosh it's a big one. And when I look into it, I'm like, okay, the next time I'm gonna go is definitely Mac is something which is the best operating, Macintosh is the best operating system, and I'm definitely gonna get it. So this is again squaring effect in action. This I have got it from one of the visualization over the internet, but definitely there are plenty of other examples that you can also look forward to. Now we are up for an interesting case study. Whatever we have learned about the life factor, how it is getting incorporated in our day-to-day life, we would be summarizing through a little case study. Perception of 3D graphs. So this is again taken from internet, and what exactly we are trying to communicate here and what the statistical meaning that has been communicated are two different things. For me, what I see, if the blue sector is in front of me and it's exploded a little, it is the biggest one. While the green one, which is at the very back, but represents the exact same percentage, that's 30%, looks smaller to me. So if blue, say, is a sales of company A, green is the sales of company B, I would be always thinking that company A sales is higher than company B in a 3D persona. So this is how we should not, 3D graphs are to be used very carefully. And personally, I won't vouch for 3D graphical representation because they introduce a lot of life factors. Increasing amount of life factors because of their perspective, also because of how the 3D, how we presume 3D in general. So if you want to communicate the statistical meaning right, this is one example where it might not be communicated correctly. So this is again another Macworld 2008 keynote that I picked up. And again, as you can see from the interesting representation of the smartphone market share, 19.5 and 21.2. 19.5 represents Apple and 21.2 represents the other. So Apple is actually not doing very, very great. But when we look into that, we see, okay, green being the color which is in the front representing to us, it's almost the same, and we will just look at from our eyes and trying to make an interpretation through it. The second one also shows the use of texture and patterns. So patterns also tend to give us a different overview, along with 3D introducing patterns would again introduce a lot of life factors. So these are some of the examples which you can see in different keynotes or different magazines or newspapers, sales tech pitch, we see pictures maybe where such introduction of life factors is highly seen in our day-to-day life. So these are the three takeaways: 3D perceptions, the addition of art. Statistical meaning is very hard to comprehend here. Overall, the takeaway from this case study would be, whenever we are seeing such graphical representation, we should give a thought, take a moment, a step back and understand, is the communication, is the graph communicating exactly what the statistical meaning associated with it, or the graphical meaning associated with it? Take a step back, analyze that, and it will definitely give you a different perspective of how exactly it should be. Okay, we are at the end of the sessions. Takeaways: do not violate the primal instincts of a human. We saw a lot of examples where, through the volume, through the squaring effect, through different colors, through how the 3D perception of the pie chart has been represented, our primal instincts are violated time to time. So do not do that. Use consistent scale. Avoid life factor. Reduce cognitive load. Whenever there is a complex representation, try to make it or break it into simple modules. If it's a complicated representation, maybe the first instance could give the required information, and when you hover or click on it or add those effects, it could give you more information. So introducing everything at first and giving the user the information might not be very accurate, and it increases the cognitive load. We humans are not very good in taking all the informations together and crunching it. At least I'm not very good. I get really confused when I see a lot of different representations coming in. I'm like, what exactly are they communicating? Could you break it down for me? So do take a look in that and how exactly we can reduce this cognitive impacts. So I would like to present a special thanks to Professor Dr. John F. Tripp. So I was taking one of his classes, and these concepts came very handy for me. And I wanted to introduce the same to all the audience out there. And here are all the links that I have used, or resources that I have used in my presentation. Also, feel free to reach out to me on Twitter. Saya Banik is my Twitter handle, and this is my email address. I'm very active on Gmail, so always refreshing. So if you have any questions, feel free to reach out to me there. I would be happy to take any questions and respond back as soon as I can. Thank you, everyone, and thank you for listening to the session. I really appreciate it. Thank you.